can scratch our way to Edmund's planet.
Well, what about fuel?
Not enough. But I have a plan.
Black holes, what they look like and where they go, have fascinated both filmmakers and astronomers alike. But that was all theory and part imagination. We've never actually seen one.
It's all black.
Until today, with this historic announcement in Brussels.
101 years ago, someone discovered a streak of light, which is plasma shooting out of the center of the Milky Way, marking the supermassive black hole. I never believed that this black hole was as big as people said, until we saw that.
This seemingly small orange glow is actually a supermassive black hole. It's 55 million light years from Earth in a galaxy called M87 and is over 6 billion times the mass of our Sun. A small image that has made scientists very excited.
It's so much more exciting than just a ring-sized smudge. I mean, this is our very first glimpse of a black hole. We're gazing into the maw of a black hole. And this is something that theories predicted for about a century. This is something we've had indirect evidence of for years, with stars whizzing around the heart of galaxies where we know there's a black hole lurking there. So to actually gaze into a black hole is really exciting, and it helps us explore new physics too.
But what are we looking at? A black hole is where matter has been crushed and condensed into a tiny space by gravity. Here in the black hole, all the normal laws of physics literally disappear. Nothing can escape this vortex, not even light. But if there's no light, what are we seeing? The ring we see is the event horizon, a violent place of gas and radiation that sits on the abyss of the black hole. It's taken so long to get this image because it's taken a global effort. One radio telescope was not enough. 8 of them from around the world helped to visualize the black hole. Scientists said it creates the same level of detail as being able to read a newspaper in New York from a London street.
The light that's coming around, being emitted from these accretion disks near these black holes, has to go through the very dense part of the galaxy, propagate out through the galaxy, across interstellar space, through our galaxy, through our atmosphere, down to these telescopes. So it's an extraordinarily difficult to, well, there's many possibilities for that light to be corrupted. So it's as a technical feat, it's quite phenomenal what's been achieved.
This historic moment confirmed that today's astrophysicists are standing on the shoulders of one particular giant. Albert Einstein predicted the black hole just over 100 years ago.
The image is consistent with Einstein's theory of general relativity. So it gives a shadow, which is the shadow produced by tracking the way in which light would move very close to the black hole. It has some sharp features, which is again predicted by Einstein's theory of general relativity. So it's both a confirmation of Einstein's theory of general relativity, but a new vista and a new type of astronomy that's being announced today.
Today, a huge leap has been made, one that makes our universe appear slightly clearer, but is still full of mystery and wonder far beyond.
Well, I'm joined now by Dr. Becky Smethurst, who's an astrophysicist from the University of Oxford. Dr. Becky Smethurst, there's obviously a wow factor here when you're looking at an image from 55 million light years away. But what does this image actually tell us?
Yeah, it might be quite hard to some viewers to sort of understand what it's showing us. You know, my sister texted me today and said, oh, the giant orange blob. And yes, it is a giant orange blob, but it has a hole in the middle, and that is the crucial bit. That hole is showing us the edge of where light is and then where light isn't. And that is the black hole that we're seeing for the first time.
But I mean, I hope this doesn't sound too dense, I'm sure it does, but that hole in the middle doesn't look that different from the black around the outside, so...
Yeah, so the black around the outside is the blackness of space, so empty space basically around that black hole in the very centre of the galaxies. The black in the middle is not empty, it's full of matter. It's just so dense that light can't escape from it anymore. And it's amazing that we've been able to even see this. We can see the material around the black hole that's glowing because it's so hot from how fast it's moving around the black hole. And we've been able to use that light that we can see around the black hole spiraling inwards to test gravity in a whole new way that we've never been able to test it before. So when Newton first came up with his theories of gravity, we could test it on the Earth and our equations worked. And then Einstein came along and said, actually, that's not right. And when you look on the solar system scale, you need different equations. And we tested that there, and then we tested it in galaxies with how stars move, and he was right again. And now finally, we can test it on the black hole scale with these huge masses and find out that Einstein was right again.
All of that to prove that Einstein was right.
Exactly.
But now that we've seen it, what would it feel like?
Yeah, it's an odd thing because people say, well, can we not go to a black hole and can we not report on this, what we see ourselves? Could we maybe send a probe or send a human in a spacecraft into the black hole itself?
Yeah,
But
never mind man or woman on the moon.
Yeah, exactly. Let's send a man to a black hole.
Yeah, why not?
Exactly. But the thing is...
You're volunteering, I'm
No.
assuming.
Because the reason why I don't want to volunteer for this is because the closer you get to a black hole, the stronger you're going to feel its gravity. And in fact, if I was falling feet first into a black hole, the gravity would be so much stronger at my feet than at my head that I'd get stretched out like spaghetti. It's a process called spaghettification, which is like my favorite word in physics ever. And you would end up basically as just a string of atoms just from being pulled apart by the gravity of this black hole. So even if we could stop that happening and fall into the black hole, you'd never be able to get out of it. And you'd never be able to send a message out of it either to tell people what you saw and what you found.
I mean, how do you know about spaghettification if you haven't actually been there, felt it? I mean, how did Einstein know any of this? This is all sort of too much for me to grapple.
Yeah, and this is the idea that we've come up with a theory to explain what we see in terms of like gravity of the Earth going around the sun. It's not that different when we think about saying stars going around a black hole in the centre of our galaxy, or this material going around the black hole in the centre of our galaxy. And so it's testing those theories. And we've actually observed for our own galaxies, the Milky Way, the black hole at the centre there, we've seen stuff falling into that has been stretched out as well, some gas that's fallen in and been stretched out like spaghetti.
Well, so is imaging the Milky Way the next logical step?
Yeah, exactly. So the EHT, which is the Event Horizon Telescope, which has taken this amazing image, actually most astrophysicists thought that the image they were releasing today was going to be of the Milky Way, so we were quite surprised when it wasn't, and that it was M87. So we're hoping that in a couple of months' time they'll release that image as well that's the Milky Way black hole. But that's a lot more difficult to see because it's in the centre, and in the centre you've got more stars and more gas and more dust, so you kind of can't see, you know, past the trees to be able to see that black hole itself, whereas this one, we're looking out of our own galaxy and we can see it much more clearly.
So you're not telling me this is a bit of a letdown that you wanted the Milky Way instead? I mean, you're asking for the moon.
Exactly. We were not let down, we were a little bit sort of like, oh, but that's still really, really cool.
This is a really big day for you.
A massive day. This is going to go down as one of my favourite days, I think, in terms of astrophysical results ever.
Dr. Becky Smethurst, thank you very much for joining me.